Hello students, my name is Sumit Mehta. So in today's lecture we will discuss about what is Bayes theorem and we'll discuss further on Bayes theorem and theorem of total probability. Okay, so let's start with what is Bayes theorem. I'll give you one example like, so consider that there are two bags, let's say bag 1 and there is one more bag 2. Okay, so bag 1 contains two white and three red balls, and bag 2 contains student four white and five red balls. So, if I say that one ball is drawn at random from one of the bags, we can find the probability of selecting any of the bags. So let's say the probability of getting bag 1 selected is half. Probability of bag 1 is half. Okay, or the probability of drawing a ball out of a particular color from a particular bag, let's say, which means, in other words, we can find out the probability that the ball drawn is of a particular color. So if I have given you probability of getting a white ball, so in this case there will be two cases, probability of getting a white ball if bag 2 is selected plus probability of getting a white ball if bag 1 is selected. So you need to apply this formula, student. Okay, and basis on this, because probability of getting a white ball, you will get the white ball from bag 2 also or bag 1 also. So I have considered here the two cases, probability of getting a white ball when bag 2 is already selected and probability of getting a white ball when bag 1 is already selected. So this will give us the probability of getting a white ball. Now we will discuss about theorem of total probability. So student, this is what Bayes theorem states. Total probability. Okay. So let's say E1, E2 up to En be a partition of the sample space, means there are n events, and suppose each of the event has non-zero probability of occurrence. So I can write probability of occurrence of A, let A be any event associated with S, and S is the sample space. Okay, so I can write this as probability of occurrence of E1 given A given E1, E2 into probability of occurrence of A when E2 is already occurred. So up to probability of En into probability of occurrence of A when En has already occurred. So student, this I can write as J to N, 1 to N, where J goes from probability of Ej and probability of A given Ej. Okay, so this is what total theorem of total probability states. Okay, the proof of this theorem is, students, not in your syllabus actually, because CBSE will not ask this. Okay, let us discuss one question on it so that it will become more clear to you guys. Okay, so students, here is the question which states that a person has undertaken a construction job. Okay, the probability are 0.65 that there will be strike, 0.80 that the construction job will be completed on time if there is no strike, and 0.32 that the construction job will be completed on time if there is a strike. So determine the probability that the construction job will be completed on time. So let take A be the event that construction job completed on time. Okay, and B be the event that there will be strike. Okay, so now we have to find out that the probability of A. Okay, so student, I can write this as from the Bayes theorem. So this is the formula to get that we have got from Bayes theorem, which states that probability of completing or the construction job completed on time is depends upon probability that there will be strike and probability of completion of A when there is strike. Okay, and probability of no, there will be no strike into probability of completion of task when there is no strike. So we know the probability of strike is 0.65 into probability of getting work completed when there is, if there is a strike, is 0.32. So this is 0.32 plus probability of that there will be no strike, it will be 0.35. 1 minus probability of strike, and probability of completion of task when there will be no strike is 0.80. Okay, so if you solve it, you will get, student, so which is 0.488. So that is the probability of construction job completed on time. So I hope, students, now you are pretty clear about how Bayes theorem is very helpful in solving questions. Okay, and in the next lecture also we will discuss some more examples on this. So stay tuned for that lecture, students. Thank you. Happy learning.